How to use the TubesT and basic functions. The software usage process is as follows. Add parts. There are several different ways to add parts. For example, drawing parts. Supervisor chooses round tube. Make a round tube. Click OK and the supervisor section is finished. Then add a branch pipe. It needs to be T-shaped connected to another round tube. Just cut off the overlapping parts. Click OK. This part has been imported into the software. After adding parts, you can choose to import other files. Then select the corresponding IGS or SAT drawing. The parts will be placed in their respective section groups. Double-clicking a part will toggle the display of the main interface. Use the middle mouse button to zoom in, zoom out, or drag in 3 dimensions. Press F4 to restore the default view. Hold Shift and drag the middle mouse button. Rotate the part about the axis. And double-clicking the left mouse button near the part. Bring up the view window. Switch view direction. These are all commonly used methods for viewing. The next step is to set up the setting process here. This refers to changing the processing path or direction. Not setting processing speed or other parameters. Commonly used processes in laser tube cutting. For example, lead wire. Select a graphic on the part, or directly select the entire part's leader line. For example, select straight lead type, angle 90 degrees, 2 mm in length. Once the lead wire is confirmed, it's done. Other commonly used processes include weld seam compensation. This part. To make trapezoidal splicing of round tubes. If no treatment is done, process directly like this. Due to wall thickness, interference may occur during splicing. In situations like this, weld compensation can be added. The software will project the inner wall contour onto the outer wall. Cut off the interfering parts to ensure that the parts can be pieced together. Let's simulate the cutting path after adding welding compensation. Step 3. Auto nest. First, set the quantity of each type of part to be processed. Process 5 of each. Besides this batch setting quantity, you can also set it directly. After setting the quantity, automatic nesting. This section contains information on pipe materials. You can see different cross-section groups correspond to different pipe materials. They won't mix together. Pipe material information needs to be set. For example, the total length of the pipe is 6 meters. Enter 6,000 millimeters here. This refers to when the master chuck reaches its limit position. Clamped pipe. Length from the end to directly below the cutting head. Cut-off distance. It's this piece of scrap that you can't cut. If the equipment has a collision avoidance function, 3-disc pipe cutter, it can achieve 0 waste. Then fill in 0 for the cutoff distance. If the equipment does not have obstacle avoidance capabilities, 2-chuck pipe cutter, after measurement, each time, a length of 200 cannot be cut. Then fill in 200 millimeters. Pipe quantity. Here, due to most scenarios, we have enough tubes. That would allow you to determine the total number of tubes. Enter a relatively large number, such as 999. Common edge type here. First, mark congruent edges. The spacing between parts here. It refers to the spacing between parts that do not share a common edge. Because the shared edge is controlled by the following part. Zeros are not allowed to be filled in the spacing between parts. We directly determine the obtained layout results. We can see, each row represents a sorting result. You can click to switch the preview. For example, in this nesting result, this is clearly a case where the parts share a common edge, and they cannot share a side here. Maintain the set part spacing. This is the name of the sorting results. And the final exported processing file. The names are consistent. The default name includes the section type and size. Therefore, during the sorting process, no need to calculate how many cuts to make yourself. Simply fill in the desired number of parts. The following is detailed information about the sampling results, including the total length of the tube and the number of remaining parts. There is also an intuitive thumbnail. If fine-tuning of the sorting results is required, for example, put this part at the very front. You can click on the part by moving the floating window forward and backward, rotating, reverse delete buttons, etc. Make simple adjustments. Then comes the fourth step, sorting. In fact, after adding parts and nesting, the software will automatically sort them. The default sorting strategy is this: sorting from small to large along the y-axis. That is, from the head to the tail of the pipe. This default sorting strategy can already meet many situations. I won't expand on other sorting strategies here. To verify if the sorting is appropriate, you can check the cutting sequence by displaying the number. A more intuitive way is to use simulation, since simulation may be used more often, so I will explain it in more detail here. The first is static simulation. Click forward and backward directly, where you can see the color change. Blue represents the cutting path that is being cut, and yellow represents the completed cutting path. Or directly drag the progress bar. You can also see the sorting effect. The second is dynamic simulation. Click the simulation button. The cutting head will be simulated, the actual tool path and sorting. At this time, click forward and backward, first and last. You can change the simulation speed. If you select one or more shapes, the simulation will only simulate the selected shapes. You can switch views during the simulation, such as switching to the main view, or press F4 to restore the default view, if the toolpath and sorting are confirmed. You can enter the final step, export for processing. After getting the nesting result, click Export. Here you need to select a folder. Not to name the file, click OK after selection. Each nesting result will be saved as a processing file. The name is the one displayed in the software. Format is as. We have just completed the last step in the process, export in DDEX format, which can be given to the machine for processing.